Hello and welcome to our special one-of-a-kind ArcSight video. In the next 80 minutes, you will see how ArcSight has evolved to deliver a faster security operations to achieve our dream, a self-defending enterprise. It will be a scenario-based demo with 19 scenarios, including topics like layered analytics, security operations automation and response, Galaxy, our newest threat intelligence offering, along with others. This is ArcSight 2022.1. Let's start.
In our first scenario, we'll cover ArcSight's arguably most differentiating feature, layered analytics. This is a term we use to show the successful marriage between our mature real-time correlation capability, known as ArcSight ESM, with our newer technology, ArcSight Intelligence, our UEBA batch analytics solution. We see both of these layers as fundamental to our solution, providing actionable insights to our customers so that the most important threats float to the top of the analyst queue. In this high-level ArcSight architecture diagram, you can see that the red boxed components provide advanced detection to ensure full coverage of the threat spectrum, no matter how low and slow adversaries may be moving within the environment. We'll prove this with an example, walking you through the life of a SOC analyst who finds this inside threat within the environment. The gentleman named Joshua Newman, using his PC, who happens to execute a PowerShell script, followed by a remote desktop session being opened. These two events, no matter how non-critical they appear in isolation, do provide significance to the analyst because they have been happening back to back, and our real-time correlation engine detects this behavior, flagging it as a medium-level alert, but being only medium level may not appear at the top of the analyst queue. So what we do is to utilize our top 5 riskiest users, which includes Joshua Newman, which also marries with our correlated alert and combined becomes a critical level incident in our ArcSight SOAR engine to attract the correct level of our analyst's attention. This is layered analytics in action, UEBA results feeding the correlation engine with the business outcome of auto-generating the most impactful incidents by moving the threat to the top of the analyst queue and enabling them with auto-response capabilities. We'll demonstrate this now. After logging into the ArcSight Fusion UI, this is our single pane of glass management interface, the analyst now clicks on the Respond button on the left to open up the case management screen. On the top left, we now see all cases, and even after sorting by severity, there remain multiple urgent cases at the top, so we only focus on the open cases by clicking the button with the same name. To select the top urgent case, we see that it appears to be an attack kill chain by a suspicious user, Joshua Newman. And what is interesting to note is that this user also appears to have run these two attacks back to back. We can drill down and find that this is indeed a correlation event coming from the correlation engine. Now I want to find out how this user came to be flagged as suspicious by going back to my dashboard and then into the analytics dashboard. One of the best views is to review the UEBA entity risk. We can drill down into the user's view and then explore to visualize all the risky entities. In the graph view, I can click on the timeline and I can review all of the risky entities. Indeed, I see Joshua Newman as one of the most suspicious users in the last 30 days. By clicking on the timeline, I can focus in on particular areas. We can see that although his risk score reached a peak of 100 following a sequence of not so innocent activities, his behavior started to stabilize and become normal, causing his risk score to decay over time. Then I click on the eye icon to make things more visual, also providing the overall tactic names mapped to the MITRE attack framework. It's quite a history of suspicious activities. If I click on the initial access button, I can then see where he's been logging in and at what times. Unusual working hours, which could of course be due to the corona pandemic virus, but as everyone has been working from home, sleep patterns have been negatively affected for almost everyone that I know. In itself, this may or may not be a problem. Instead, let's have a look at his command and control related actions. There are far too many alerts on this particular tactic for this user. It looks bad, and I want to focus and get to the bottom of this. To make actions stand out and get more of the critical and extremely critical suspicious activities, I move the risk slide all the way up. Let's have a look at his latest exfiltration activity. He seems to have uploaded a significantly large amount of data to a website on first access. The quantity of data is flagged as it significantly exceeds the baseline for other users. So that makes two anomalies back to back, providing us a clear indicator for a possible targeted attack campaign. This is what we see with current adversaries. Upon landing on the systems, they time slice their activities, placing long wait times in between their anomalous activities which might otherwise fail to trigger static threshold-based detection. We keep track of their normal behavior even when the entities appear to go dormant through the suspicious entity lists within our real-time analytics engine. Without losing focus, let's quickly look at the correlation to see how it got the hint. I click on the resources to look at my active lists, here used to track our suspicious entities, where we receive dynamic insights from our UEBA engine. As you can see, we have these top 5 riskiest entities, and yes, sure enough, our suspicious user Joshua Newman is listed and ready to be used within any of our real-time correlation rules. Finally, let's take a look at how this really happened under the hood. ArcSight Intelligence adds points based on an individual's abnormal behavior against his own or his group's calculated baseline. This is a tried and tested method to uncover insider threats. I would argue that it's impossible for a malicious user to look identical to the legitimate owner of an account, because at some point they're going to do something unusual or out of character. For example, they might use a different executable, connect using a different protocol, log in an unusual server, and so on. So if you're watching from enough different perspectives, and if you're evaluating enough baselines, then it doesn't matter how they got in, they're going to trigger an unusual behavior somewhere. If you have machine analytics asking the right questions for your environment, your SOC has a fighting chance to find those malicious actors before the full breach can be executed. Our real-time correlation engine is running out-of-the-box content with multiple concurrent detection rules, firing in memory, waiting to catch these attacks in real time. In this content, we see an example MITRE attack chain model, which leverages active lists populated in real time by insights generated by our UEBA engine. Sure enough, our suspicious user Joshua Newman is captured here during the life cycle of the attack, and upon executing the attack chain, triggered detection within the correlation engine. In summary, the behavioral insights provided by our UEBA engine, when coupled with the real-time detection of the correlation engine, provides us with the high-fidelity findings we need to maximize SOC productivity. This is what we call layered threat detection in ArcSight, and this ends my first demonstration. Thank you. In scenario number 2, we'll demonstrate ArcSight's log collection capabilities and differentiators, focusing here on custom event log parsing. ArcSight is the inventor of Ceph, the Common Event Format Protocol, which is a de facto standard in the industry. In fact, our competition still enjoys the benefits of Ceph parsing to get a jumpstart in their own log coverage. For those rare cases where an existing parser may not already exist, ArcSight provides customers with several options depending upon the complexity of the log source. We'll show 2 of them today. For simple logs, we have ArcSight Flex Agent Wizard. For the more sophisticated raw logs, we provide the Quick Flex Wizard. The Flex Agent Wizard is a simple UI-driven tool that proves to be quick and easy for even the inexperienced SOC analyst or SIM engineer, taking only 6 steps from start to finish. However, we know that logs today are not always that simple, and we have another utility for more advanced, complex requirements and use cases. The Quick Flex Wizard also provides a UI-driven, wizard-based approach, giving the advanced user additional power where it's needed. Let's demo the first option, the Flex Agent Wizard. Let's take a look at the sample log file that we'll try to parse. It's a fictitious but typical simple log file. As you can see, each event appears on a single line, with each line following a very simple pattern. The events are delimited by a comma, starting with what appears to be an IP address of the device, the date and timestamp, source IP address, source port perhaps, and so on. Let's start the Flex Agent Wizard. In the Welcome screen, we start by selecting the log file. We then give a friendly name for the project, which becomes also the file name for the parser file that will be generated. We can see that the tool has already made a guess as to what the correct delimiter should be, the comma, which is correct. The other parameters are also selected correctly. We click Next. The next screen in the wizard allows the user to map the tokens found in the log file to their corresponding Ceph schema fields, all from a drop-down menu. For example, the IP address that appeared at the start of each line we map to device address, the timestamp to device receipt time, source address, source port, and so on. Where there isn't a direct mapping to the Ceph schema for a given token, we can simply choose one of the custom event types or custom token types. This allows us to extend the schema as needed. Finally, we reach the stage of defining the vendor name from a drop-down list and also the product name as the log source. Now we can actually create a smart connector with the custom parser built in, or we can simply save the parser itself, ready to be deployed en masse to existing smart connector deployments. Let's have a look at the generated parser file. And sure enough, we see all those tokens have been mapped to the relevant Ceph schema fields. We could make further modifications here, but for this example, this is sufficient. Let's start now with the second demonstration of our Quick Flex wizard. In this scenario, we have another fictitious but much more sophisticated log file. Each line provides events in a slightly different format, though they seem to have some common patterns. Each distinct format we call submessage. We'll tokenize these and associate them with their own subparsers, all within a single tool, and again resulting in a single, more complicated parser file automatically generated. Let's make a start. Here's the high-level overview of the simple steps involved. Clicking Create New, we start a new project, we fill in the initial details, device vendor, device product, we select the log file, the sample log file we wish to parse. We can browse that log file, and we'll pick one of the lines here, one example event from this log file for our example today. Click Base Regex Editor. As you can see, the QuickFlex Wizard's built-in regex engine has already made a guess and populated automatically the base regex section. I click the Matching Details button, and I can see that we already have 4 tokens generated, and we can review some sample values associated with each one. Click Save to that token generation. Note below how those 4 tokens have now been displayed. We can now go in and change the internal name for each of the tokens to something more referenceable and easy to remember, the type, and where relevant, the sub-format for that particular token. We can also select the actual assignment here, which is the mapping to a particular Ceph schema field. Finally, we choose for the submessage the ID or the token that is going to be used to select this particular submessage, and we can also allow for additional data where needed. Clicking Save and OK. If we go back to the log file itself and click Refresh, we can see those events that have been successfully parsed with the highlighted tokens indicating what has been extracted with the parser file created thus far. Once I'm satisfied, I can click Generate Parser and export it. All of this automatically generated. This ends the demo. Thank you. In scenario 3, we'll demonstrate a small selection of ArcSight's out-of-the-box log collection capabilities and differentiators. First, we'll show our Office 365 Smart Connector using the REST API for native cloud support. Second, we'll show you a non-API based connector grabbing text files deposited into an AWS S3 bucket. Finally, we'll show collection from an on-prem deployment of the famous vulnerability analyzer Rapid7 Nexpose. Our first demo is from Office 365. We install the ArcSight Smart Connector from a large range of log sources out of the box. We then provide the necessary details like tenant ID, the client secret, etc. We then finish the configuration, outputting the results to a Ceph file, which we'll take a look at later. Now we'll log into a live Office 365 system, where we see the screen showing the overall mailbox, MS Teams, login and other activities. Our connector by default will collect all of these events, including Azure Active Directory, SharePoint Online, and so on. Finally, I'm going to open the Ceph file that was generated to show you the correctly parsed and categorized events. This is so critical I want to pause here for a second. What we're looking at is a user attempt for a login, which always gets categorized as authentication verify and with an outcome of attempt. This way, newer analysts who may not know Office 365's event taxonomy can enjoy the benefit of a standardized language common across all of their security and cloud solutions in their SOC. This ensures that ArcSight content based on these categorizations will always fire reliably, surviving technology replacements, migrations, etc. Our second demo is for the AWS S3 bucket. It's unique in ArcSight. It's a superconnector allowing a single instance to support a large range of unique log sources. 2 types of polling are supported, providing an additional advantage for MSSP scenarios. Finally, all AWS regions are supported, including the US government as an example. Our third demo is for Rapid7 Expose, which is an on-prem VA solution previously known as Nessus. The smart connector can run fully automated like the others, however it also supports a second option called Interactive. Interactive option allows selective import of VA scan results into ArcSight's asset and CVE database. This is exactly the option I'm going to demonstrate today. After the initial configuration, I select one or more of these destinations, Amazon S3, Microsoft Azure Event Hub, or our own Transformation Hub. I can choose to send the past events to any of these, but to keep it consistent, I'll choose the Ceph output. Here we select which of the 2 scan reports available we'd like to import. Once we click this button, ArcSight automatically imports them into its asset DB, later to be used in incident priority calculations. Finally, I open out the Ceph output to show correct parsing of the VA report. This ends the demo. Thank you. Let's start our demo of the fourth use case, focusing on ArcSight's real-time correlation capabilities. Real-time detection has been at the heart of ArcSight since day one, and we continue to push the envelope to achieve ever higher detection results. Correlation is how we achieve this. There are 4 main topics we'll cover today. We'll start by describing our approach to categorization. Then we'll show you 2 different methods to create correlation rules. Sigma support will be shown next. And then we'll finish this section with a brief look at our distributed correlation mode. The challenge with correlation rules is that they have a real risk of becoming outdated the moment one security vendor, say EDR, is replaced with another one, generating similar events but with a diverse logging taxonomy. Our goal is to unify logically identical event categories under a single language, irrespective of any particular or proprietary vendor taxonomy. Let's start with our first example from the ArcSight Fusion Search UI. A basic yet powerful search query can be constructed using just the mouse to select intelligently from a context-sensitive range of operators, fields, and actual values. The search results include all events from EDR systems in my environment. I see McAfee, Symantec, Windows Defender, all categorized as antivirus, which is tagged against each and every event of this type. By default, ArcSight Smart Connectors embed this enriched information within each event at the time of ingestion and normalization. Now we'll be creating a correlation rule leveraging these standardized and powerful event categories. First, we'll use our modernized web interface where we'll write a vendor-neutral, single correlation rule to find all EDR and endpoint protection events using the same antivirus category. I like the web wizard, however, power users often prefer to use our mature ArcSight console to reach the full potential of ArcSight's content development system. This is what we'll show next. Rule building takes place in what we call the Correlation Conditions Editor, or CCE for short. The ArcSight CCE is a powerful drag-and-drop interface designed to aid design and maintenance of content for today's advanced query and detection requirements. A large selection of logical operators available, and here we're selecting the required category for our rule from a drop-down list to formulate our basic detection logic. Once we've finished, we can deploy it into the real-time engine either for immediate real-time detection, or else to run against historical events to test logic against test data, or for forensic hunting purposes. In the next section, I'll be talking about Sigma and how to integrate it with ArcSight. I start by selecting a sample Sigma rule from the Sigma GitHub repository. My personal favorite is lolbas, living off the land binaries and scripts. I pick a data exfiltration use case. I then copy-paste this logic into a third-party website, uncoder.io, maintained by SOC Prime, a long-standing ArcSight partner. I select ArcSight as the target platform and hit Convert to generate the ArcSight equivalent of the Sigma detection logic. I return to the CCE console and paste the converted rule text into the free text field. When I click OK, see what happens. The content gets populated into the CCE and automatically parsed, just like any other ArcSight correlation rule. I will now show you another real-world example of how ArcSight takes this integration to the next level by merging 2 net new Sigma rules. To start, I repeat the same steps to convert the first Sigma rule, this time the MITRE Bazaar execution rule, originally written by Zeke. Once I hit Translate and Copy, I can then paste it into ArcSight. Merging is an advanced technique to detect otherwise low and slow evasive kill chain techniques. Merging these 2 rules intelligently, we can devise a stronger rule that is tougher to evade and forms a core capability upon which our customers depend. I'll make up an example here, but you will understand the main concept. I will alert only when the file hash of the first rule matches the file hash of the second, by composing a super correlation rule or higher priority of an alert. Now I'm preparing the second rule as rule 2. Once I'm happy with it, I see the first rule appears at the top with the second beneath, combined by default with an OR condition. We switch the join condition to an AND, leaving only to ensure that the file hash from the first rule is joined or matched against the file hash of the second to implement our supercorrelation logic. This is a prime example of leveraging simple building blocks to form more sophisticated correlation logic by layering tested and proven content to meet increasingly more complex use cases. Once I'm done, I click OK and click deploy to make the new rule active by deploying into the real-time rules folder. Finally, I will show a modernized architectural design that has enabled us to meet the expanding correlation needs of some of the world's largest organizations. Welcome to Distributed Correlation, ArcSight's advanced correlation cluster mode, specifically designed to support real-time detection for high EPS, high-speed environments, leveraging our mature correlation technology. In this mode, we decouple the correlator function from other components, such as aggregation and persistence, facilitating cost-efficient allocation of CPU, memory, and storage resources to each functional component as needed. This enables our customers to utilize a cluster of smaller nodes, some allocated to correlation, others aggregation, whilst all working in concert within a single logical ESM instance, and already proven by one of our larger customers to reach with 300,000 EPS. This ends demonstration 4. In scenario 5, we'll take a brief look at the unsupervised machine learning models available within ArcSight Intelligence. Several hundred predefined machine learning models are provided out of the box, covering a large range of common use cases. The degree to which an anomaly contributes risk to entities can be customized to your environment by tuning the weighting associated with the anomaly. The out-of-the-box models can be readily augmented using the Custom Models feature, where you can develop and train your own analytics models and load them into the system. Intelligence will then integrate these models as part of its own analytics. Custom models can be developed using your own choice of machine learning tools. They can be then imported in Predictive Model Markup Language, or PMML format, using the Tuning REST API, which is fully exposed and available to test via standard Swagger interface. In addition, ArcSight Intelligence anomaly alerts and risk scores can be ingested by ArcSight ESM to allow correlation rules that detect certain patterns of anomalies or considered entity risk to provide additional insights and context to real-time threat monitoring. For example, ESM could look for anyone that accesses a particular resource and has a risk score higher than 80. This concludes our demonstration. In scenario 6, we look more closely at our unsupervised machine learning UEBA solution, ArcSight Intelligence. Traditional security applications concentrate on finding threats using rules and thresholds or pattern matching. These are excellent techniques for finding known threats, but don't work well for catching evasive and evolving insider threats. ArcSight Intelligence employs unsupervised machine learning to establish unique and ever-evolving normal behavioral baselines for each entity it encounters, without the need to label data or train models that is associated with supervised machine learning techniques. A full description of the maths involved is beyond the scope of this demonstration, but the equations were developed by Interset and are based on statistics, probability theory, and expected utility theory, using a mathematical architecture based on a shallow neural network with a logistic or Pareto squashing function to generate the final risk scores. ArcSight Intelligence can distill billions of log events into instances of statistically unusual behavior or anomalies surfacing the riskiest entities in your organization, and thus providing a manageable number of high-quality threat leads from which you can begin your investigations. ArcSight Intelligence presents the list of all entities of a given type ranked in order of current risk. All risk scores are normalized values between 0 and 100 to allow easy comparison of relative risk. It allows you to explore all instances of anomalous behavior it detects. These are summarized in a matrix and listed in more detail on a timeline. You can explore each individual anomaly in more detail. For example, this anomaly indicates that Alan posted a significantly higher volume of data to a specific website in an hour when compared with his peers. Other types of anomalies are generated when Alan's actions deviate from what is normal for him. Each anomaly's details dialogue includes a description and a visualization specific to the type of anomaly. In addition, you can view all events which contributed to the generation of an anomaly. This, in combination with simple, easily comprehended descriptions of what each anomaly means, present a level of transparency that simply isn't available with other types of machine learning. This concludes our demonstration. In Scenario 7, we'll demonstrate the persona-based dashboard features of the unified ArcSight platform. We log into the ArcSight Fusion user interface as admin to show all available options. This is the single pane of glass interface to everything ArcSight related, customized by persona. Let's see some of the default dashboards available out of the box. How's my SOC running dashboard at the bottom catches my attention. As you may have guessed, this is built mainly for SOC managers. More than just eye candy, this dashboard informs the SOC manager how they can reduce their organization's exposure time by improving the detection and response times. Case timeline is interesting as it allows me to predict future SOC headcount requirements as my data capacity increases over time. Let's check a dashboard more focused on the analyst entity risk. Here I can see the suspicious entities in my environment, which is the outcome of my ArcSight UEBA solution. For the last 3 months period, we have identified 22 active risky entities in total. We'll now dive more deeply into the creation of flexible dashboards. I shall add a new dashboard to be utilized by all the analysts in my environment. After providing a name to the dashboard, I will build out from a list of available widgets. Here, Active List is good for reflecting key outcomes from our correlation engine, whilst Analytics Pipeline gives a high-level overview from our behavioral analytics engine. Going down, I'll add the Case Breakdown widget, as I'm also interested in the SOC's case statistics, while Case Workflow Analysis is critical to visualizing how the SOC is performing. A broad range of widgets combining data from across our various solutions are available to select, as we see here. For this dashboard, I will focus on the top risky entities, so I select the relevant widget from the list, again from our behavioral analytics component. I'll add this widget several times and then adjust each copy. I can fully customize the layout to best present the chosen result sets, each in a format suited to the type of data it represents and dynamically updated from their respective data sources. Whether that be the correlation or behavioral analytics engines or for our fully integrated SOAR component. For each widget, I can customize the data that is displayed. Here, I have configured the top 5 riskiest users, domains, and websites, all based off the same widget tied to our behavioral analytics data source. I'll set this as the default dashboard for my analysts, based on their specific role within the environment. Now, when an analyst logs in, this is the first dashboard that they will meet. I will now show you our administration page. Here, I'll create a user and assign her to our default analyst group. We'll now look at some of the roles and permissions based per persona. Conducting threat triage searches, managing the system, or SIM content development are completely different tasks, and we provide all the atomic permissions for selection and assignment to the appropriate group, facilitating full segregation of duties. In Scenario 8, we will demonstrate our powerful incident prioritization framework and how incidents are managed within our SOAR component ArcSight Respond. Correct incident prioritization is absolutely key to effective triage and investigation and must take into account an increasingly diverse and richer set of indicators in order to focus the analyst's attention. Respond acts as the glue, arbitrating between multiple sources of threat indicators or influencers within the SecOps ecosystem to ultimately determine the all-important incident priority that will drive the analyst workflow. We call this multidimensional prioritization, and we'll start by looking at each of these influencers in turn. Some components are covered in more detail in other demonstrations. Our correlation engine incorporates a mature threat-level modeling calculator that tags each event in real time. ArcSight Intelligence leverages sophisticated statistical modeling to provide risk scores to entities. The layering of both machine learning and correlation in itself builds a third, even more rich source of prioritization, whilst our basic and premium Galaxy Threat Intel services further contribute valuable live, public or curated threat scoring against known bad actors. And finally, ArcSight Respond provides the customer full and ultimate control over how security incidents or cases are generated and assigned a severity to best accommodate each organization's perspective of what matters to me. Let's take a look at how all this comes together in Respond. Respond is built around a highly flexible playbook engine and includes many standard playbook templates out of the box. Each playbook can be configured to branch the workflow according to many decision tree factors, with Respond ultimately generating a new case and dynamically assigning the severity, and thus the overall ranking in the analyst work queue. The workflow is created using a powerful visual playbook editor. Here we're selecting from available conditions that will drive both case severity and the next stage of the workflow. These conditions can all be augmented and are fully customizable to the organization's SOC requirements, for example, defining normal working hours. Now we leverage Respond's broad integration capability with a CMDB to match against VIP users. We can overwrite the incident severity at any branch in the workflow and in combination with other decisions within the flow. Thus, we can update the incident severity to urgent when either a VIP user or an admin account are matched within the triggering event. Finally, we see how straightforward it is for the analyst to update, reopen, elevate, and ultimately close the case. This ends demonstration 8. Thank you. In scenario 9, we will present our enhanced investigation workflow, focusing on the user experience. The user experience of the SOC analyst is our primary focus, realized through our modern, dynamic web-based user interface, ArcSight Fusion. In this demo, we shall briefly showcase our intuitive dashboards with some of the more useful time-saving features, Fusion, our common UI shared across all ArcSight components, our simple-to-use and fast search query support, as well as some special MITRE attack visualizations. Starting with our extensive range of out-of-the-box dashboards and reports, let's see how easily we can focus the attention to a specific entity of interest by leveraging the cross-filtering feature. Here, we'll use one of our standard GDPR use cases. We observe China as one of the top destinations for traffic flow to outside the EU region. We'd now like to see how our chosen entity is reflected across the other dashboards in this report, and so we use the brush or cross-filtering tool from the available options. Having selected our chosen country in the world map, we can rapidly focus all the other dashboards to the same entity using the brush or cross-filtering tool, much like the format painter found in common office applications. Simple and easily reversible. Another common challenge during investigation is how auto-scale charts can inadvertently mask the entity of interest due to outliers in the dataset. By clicking the Exclude Data button, we can selectively hide certain entries to allow the remaining entities to surface as the chart automatically rescales. That's more like it. Now, let's combine our rescale chart with the cross-filtering feature to further reveal the relative significance of our chosen entity across the remaining visualizations, surfacing previously hidden patterns. With just 2 mouse operations, we have isolated the root cause from an otherwise opaque dataset. A painful and all too common activity for the analyst is the need to swivel chair between diverse tools, each with its own idiosyncratic UI and learning curve. Fusion UI has been designed to break that cycle and bring all the ArcSight functionality together in a single pane of glass with a common and intuitive learn once, use many interface. From the same top-level menu, the analyst can sweep between the different analytic layers of the solution. Here, reviewing the top riskiest entities within our UEBA solution and drilling into the activity timeline for a suspicious user to swiftly visualize or export the evidence that has triggered the machine learning assessment. The Dashboard tab, available across the full range of components, takes us back to the main dashboard, and now we switch context to the ArcSight SOAR solution, where we record the findings found through machine learning, attaching the exported evidence to a related security incident or case. All ready for handover between incident responders. Our SOAR component provides many features to enable effective collaboration between team members. Here we can use case tagging and also detailed case reports to share information between the respective analysts. Now we'll look at our search and hunt capabilities that provide rapid investigation workflow. The context-sensitive auto-suggestion query editor allows sophisticated search query development with fast results populating the active table and timeline panes. Search results can be rapidly refined through simple mouse actions on the event timeline, as well as drill down from column headings providing instant top-X views. Full event details are always available, regardless of the field set currently tabulated. From here, the analyst can pivot straight into third-party sites and tools for the all-important additional context. Searches can be named and saved for later review, or handed off to other team members, whilst the same search can be set to run on a flexible schedule. Nothing remains static in the analyst's typical workflow, and leveraging previously refined search queries for adaptation to a similar but new use case provides further time saving and standardization. Customizing saved searches is trivial with the ArcSight search component. Finally, let's recap on ArcSight's MITRE attack visualizations, covered in more detail in demos 1 and 15. Out-of-the-box dashboards and visualizations adapted to each persona within the SOC ensure that the most meaningful MITRE-based threat intel is presented according to role, all from within the same unified Fusion user interface. This ends Demo 9. In Scenario 10, we will show you ArcSight's case management functionality. When the analyst sits in front of the case management screen, the first thing she sees is the prioritized list of cases needing attention. The list of cases is sorted by severity to assist the analyst readily identify the important cases needing focus. The case list shows important information about each case, such as name, current owner, creation time, the case severity and status, as well as SLA progress. The analyst can search cases based on different criteria and save their search as a shortcut for future use. When the analyst selects a case from the list, the case details display events, case scope, and timeline, allowing the analyst to investigate and respond appropriately. Let's take a look at the more important case management functions together. When a case is first created, ArcSight builds a case scope with the artifacts from the events. The case scope grows and artifacts' risk scores are re-evaluated with each new enrichment. The analyst can investigate the event details contributing to a particular case. The case description, SLA compliance, and playbook details are shown here. Reports can be created based on case SLA to measure the analyst's as well as the SOC's overall performance. The MITRE attack ID detected by ArcSight shows the details of the techniques used by the adversary. The timeline shows all the activities related to the case, such as playbook executions, actions, enrichments, comments, attachments, and many others, all in chronological order. The analyst can initiate a manual investigation or response action without ever leaving the case. Finally, the analyst can record their comments and hand over the case to another analyst or group for further investigation. When the new case owner displays it, they will see the whole context and history, ready to pick up the investigation seamlessly. In Scenario 11, we'll take a closer look at ArcSight's UEBA engine, ArcSight Intelligence. ArcSight Intelligence employs unsupervised machine learning to establish unique and ever-evolving normal behavioral baselines for each entity it encounters. It then creates alerts for each instance of entity behavior that deviates significantly from the baselines. These alerts are called anomalies. The intelligence risk engine calculates a risk score for each anomaly observed. Anomaly risk is a function of the probability of that specific behavior occurring and the weighted average of the risks associated with the entity, the asset with which they interacted, and the method of interaction. Entity risk scores are then calculated by considering the entity's importance, which may be adjusted via tuning, and the aggregate behaviors observed for the entity over time. Consider an example in which Anne is observed to be active at 3 a.m. This is not by itself an indicator that anything is amiss, but it is unusual for Anne, who typically works between 8:30 a.m. and 6:30 p.m. on weekdays. Anne's risk score is therefore elevated to 15, which is still considered low risk. Anne then connects over a VPN from China, checks out an unusually large number of files from a code repository that neither she nor her peers typically access, and posts a significantly larger amount of data to a website that is unusual for her. None of these behaviors taken in isolation is necessarily a cause for concern. Rules that flag these individual behaviors would generate a large volume of false positives. But taken together, these behaviors are enough to elevate Anne's risk score here to 96, prompting security teams to investigate this potential instance of data exfiltration and any other activity in which Anne was involved. The ArcSight Intelligence user interface displays each entity's risks profile over time as a line on the matrix shown. Anomalies that contributed to the entity's risk are displayed as colored squares on the matrix, and a detailed list of anomalies is shown below the matrix. By zooming in on the matrix, you can see the set of anomalies that occurred within a specified period. The following anomaly shows that Alan's 95 attempted authentications in an hour exceeded not only the expected highest number for him, but also the average maximum for other people in his organization, which here is 2.5. Peer grouping can be performed manually, for example, to independently baseline the behaviors of a specific set of users, such as a red team. It can also be performed based on different account types, for example, to differentiate machine, service, or system accounts from human users. Automatic peer grouping is performed for certain anomaly types using k-means clustering. In scenario 12, we will demonstrate ArcSight's rich event querying capabilities, its user interface, and out-of-the-box content. ArcSight supports two types of search query. First is a proprietary query language called CYPL, or CyberRes Processing Language, designed to be an intuitive and easy-to-use English-like query language to analyze security event data. Secondly, we also support the industry-standard SQL. CYPL is made up of various elements. Here we'll show some of them. We support full text terms, field value terms, wildcards, CIDR IP addresses, in-list operators for enrichment, pipeline operators for string, math, and conditional operations. We also provide hashtag queries for out-of-the-box and reusable queries. Let's see the search user interface in action. To help the analyst get started, we provide several meaningful sample queries. The query area provides contextualized autosuggest and syntax highlighting to make writing a query a painless task, even for an inexperienced user. Here we show the timeline of results for Microsoft and Unix events received in the last 24 hours. Within the timeline, we can select a time range and drill into the results for that specific time frame. Column actions can be used to show and sort against the unique values in a given column or field. Clicking on a row instead will show the complete event details panel, from where several analysis actions can be taken. Each event has a unique URL that allows for sharing. The event can be shared by itself or entire result sets exported. We have more than 20 out-of-the-box queries and over 100 prepared reports and dashboards, and the categories of cloud monitoring, foundation, GDPR, as well as several insight compliance packs. Here we see various types of searches that can be performed. Any keyword, CIDR subnet matching, parameterized hashtag queries, full text search, pipe operators, and finally wildcard search. That ends this demonstration. In Demo 13, we will demonstrate decentralized searching capabilities, which is searching outside of the SIM data lake or unconnected data sources. We will be utilizing ArcSight's search, hunt, and visualization solution Recon for this demo. Although ArcSight comes with its own big data lake, we can still connect to data sources outside ArcSight with Recon. Everything is wizard-based, making the entire process quite straightforward. Let's first log into the Fusion environment and go to the Dashboard and Query portal within ArcSight Recon. ArcSight has a capability to connect to several data sources using standardized protocols like REST and JDBC, to name just two. In this demonstration, we'll use the connection created for an elastic data lake instance. Then we'll show you how to explore the data from within the ArcSight environment. The first step is to create a data worksheet to get the data from an index in the elastic data lake. We are entering the REST query details here, such as JSON path and URL suffix for the database. Clicking the Live Data View option at the bottom right allows me to see the data successfully, as retrieved from the index in the Elastic DB. I save the worksheet. Now we'll create a new dashboard using a template from the available options, just like a new user might do. We'll use a wizard in this next step. And once done, I'll click Finish. Now I'll add a chart. We're basically designing a dashboard from scratch. I choose the X and Y axes, and a visual wizard is telling me which dashboard is recommended for my situation. I select the 2D bar chart. Next, add a table by drag and drop of the required columns. Next, I will add filters. Finally, I provide a name for the table. We've now created a dashboard with a 2D bar chart and a timeline table, which shows the complete data set coming from the Elastic DB. This allows me to filter the data, then slice and dice it for further analysis. In our final step, I will save the new dashboard under my standard content folder before running it. I'll select only the success events and select specific users that I'm interested in. This easy filtering feature allows me to focus on specific events by selecting with only the mouse. The same feature can be used to drill down on a specific user. For example, Adam Harris will be filtered in the table below as soon as I click on his ID. The brush option is another slice and dice feature. When I select a specific timeline bar with a brush, the table shows only those events from the desired time frame. Quick summaries are possible. I could also export my results to attach to a case or pass it on to an external tool. In addition to slicing and dicing the events from the external data lake, we can also search within the dataset to further refine the results in much the same way as searching within our own native unified data store. This ends our demo. In scenario 15, we'll discuss how ArcSight is immersed in the MITRE attack framework, not just as a supported capability, but as an integral part of its DNA. The examples and proof points in this demo aim to show how fully embedded MITRE is within the ArcSight methodology. First, our own version of the Attack Navigator, particularly useful for SOC managers and CISOs. Then we'll show you the visualizations we provide for each SOC persona, even for the one-man army sim jockey. Let's start. This is the Attack Navigator, a dynamic page representing all the components of ArcSight and how they map to the attack framework. Dark colors mean that the technique is already covered by ArcSight, whereas a light color means we have not yet developed content for it. This vertical bar means that this technique is covered by detection logic found today in ArcSight's out-of-the-box default content. ArcSight real-time correlation is indicated with a blue bar next to it. ArcSight intelligence is instead shown with the yellow bar, whilst our search and hunt platform the orange. This way we can readily understand which technique is covered by which component within what we call our layered analytics solution. We're taking the analysts on a journey here, placing all the possible links at their fingertips. They can get more information by clicking the technique or other links, all without leaving the navigator window. Each technique has multiple lines corresponding to different types of content. For example, this ESM default content, which we'll cover later in scenario 19. Here come the visualizations. First, for the SOC manager. She is vested in finding out where gaps appear in the current detection logic, which this page helps her to identify. If we don't have coverage, this will be clearly flagged by color. Next is the attack activity dashboard, which is very well suited for the SOC analyst. For this scenario, let's imagine that I'm a newly hired analyst with limited or even no ArcSight experience. I'm curious, and that's why I got the job, or so I've been told. This is a real-time view focusing on a rolling time window of the last 48 hours. It provides a precise indication of the techniques and their parent tactics active right now within our environment. It's like the battlefield. Well, let's see which indicators I'm equipped to investigate. Ransomware through suspicious address. Our threat intel analyst is better suited to this one. Password spraying in the cloud. I'll leave it to our L2. Okay, as a PowerShell expert, I'll take this one. Clicking on the condition summary is optional, but it does reveal ArcSight's underlying filtering language. It looks straightforward, but I don't need to know about it right now. I was able to slice and dice from thousands of events into these 17 relevant events just based on my MITRE attack basic training and nothing else. Going through the list, the longest encoded command catches my attention, and sure enough, we have a hidden PowerShell command with a really long encoded command. Confirm true positive. Now, let's see how ArcSight helps our hunt teams and data science friends. They too can learn basic MITRE attack principles and be productive with ArcSight. Scenario 1 has more details on this topic. Let's start. Here we have 3 different tactics, all associated with our infamous user Joshua Newman, who has been up to no good. All his activities are tagged with relevant attack tactic IDs, which makes it easy to follow the chain of events that ultimately led the analytics engine to arrive at the decision it did. Attack is in the entire life cycle of an ArcSight incident, and our SOAR response solution is no exception. Taking the same incident we saw in Demo 10, let's recap briefly. Incidents have their attack tags displayed on the top right, as assigned by our analytics engine. This one has a sub-technique as well. Great. Clicking on it gives me more information, and from there I can also pivot to the MITRE or the CAPEC websites to learn more about these particular techniques. Now, let's talk about the ROI from day one questions, as this is what matters to our customers. So we want to help answer the question, am I covered against this latest threat out of the box from day one? We can answer this question if we know what matters most to us. Prioritization is the key to having the best chance to win in today's cyber warfare. As a CISO, I need to pick my battles, and this tool allows me to do just that by defining my requirements and comparing against ArcSight's out-of-the-box coverage, available for download as a JSON file exported from the navigator page we saw earlier. We add the usual suspects that target my industry the most. I need countermeasures against these: APT41, Carbonac, Cobalt Group, Cobalt Strike. I heard v4.5 was leaked 10 days after its release. I'm definitely interested in that too. Finally, I pick some cloud data sources used by my mobile workforce. I paint them red and give them a score of 1. I then load ArcSight's coverage from the JSON file and hit compare. And boom, from the 47 techniques I was interested in, 41 is flagged as covered, while just 6 left uncovered from day one. At 87% coverage, it's not perfect, but a great start, and more importantly, tells me precisely in which tactics and techniques I need to invest my valuable time and resources. In order to validate the real-world efficacy of our detection analytics, we submitted ArcSight to the Attack Evaluations Round 3 contest by MITRE Ingenuity, about as real a simulation as it gets. ArcSight were the only true SIM vendor to participate in this evaluation without EDR technology. A red team spent 2 days attacking a fictitious bank and a hotel using more than 60 techniques, which we defended along with 29 other participants. The event also proved to be a terrific purple teaming activity for our content R&D team, who then updated our default content with over 200 additional rules that were written specifically for the exercise. The real winners, of course, are our customers. Finally, MITRE Attack is not the only framework we support, as our dynamic solution allows for OWASP and other security frameworks without creating additional overhead, through a simple ArcSight technique called rule linking, similar in concept to file shortcuts in Windows. We create a single instance of the rule under default content without the need to duplicate and manage the same rule under multiple frameworks. Then we simply link it to another use case which has subfolders representing the new framework to be supported. As a direct result, multiple frameworks can be supported simultaneously. We published this guide to support our customers' SOC content teams who asked us how to leverage our out-of-the-box dashboards within their own content, a clear indicator that our dashboards are being used in the real world. Thank you. That ends Demo 15. In Scenario 16, we will demonstrate ArcSight's collaboration capabilities for the analyst, system owners, and incident responders. ArcSight not only improves the communication within the SOC team, but it also allows team members to work with and extend their reach to key players from other departments. The action, approval, and notification mechanism is a key feature to facilitate collaboration with system owners as part of the SOC process. You can define system owners for each integration point, so that before SOAR executes any action on a particular system, it will first notify the system owner with the details and solicits the owner's permission. This helps the SOC to draw in the system owners into the incident response activity and to cultivate positive collaboration. When the SOC needs to communicate with stakeholders from different units, such as IT or HR, ArcSight's existing bidirectional integrations can be leveraged with support for popular service desk and ticketing platforms. ArcSight talks to ServiceNow, Jira, and SMAX among its many integration options and can automate the submission of tickets to other departments as part of the incident response workflow. When team members update or resolve a ticket assigned in the external system, changes are automatically added back to the case, and ArcSight SOAR continues to progress the defined workflow. In addition to collaborating with operational teams, ArcSight also directly communicates with end users and their managers to involve them in the investigation at defined points in the process. The user decision feature of the SOAR playbook lets the SOC solicit others' opinion to provide situational awareness or to clarify when a user or system configuration error may have triggered the alert. For example, when an alert is triggered for multiple failed logins, instead of directly blocking the IP address from the network, ArcSight SOAR can be configured to first send a message to the end user to question their login activity before any further automated steps are actioned. This concludes demonstration 16. We will now focus on ArcSight's threat intelligence capabilities. ArcSight has taken a big leap in this domain with the launch of our Galaxy program. We have 4 core strengths, the most critical one being the end-to-end nature of our solution. We believe that high-quality threat intel is table stakes in today's threat landscape. That's why our GTAP Basic service is free for all ArcSight ESM customers, providing Circle MISP TI integration from day one. We also offer GTAP Plus, a premium TI service for SIM customers with a higher maturity level. Galaxy is the overall name of ArcSight's new threat program. Galaxy Community is the web portal, mostly geared towards CISOs. Galaxy Threat Acceleration Program, or GTAP, provides the threat intelligence service and will be our main focus today. GTAP has 2 options. GTAP Basic is the starting out-of-the-box option, providing real-time detection and response for known and well-publicized threats, like Log4j, SolarWinds, etc. GTAP Plus provides a high-confidence, low false positive premium TI service with a fixed price subscription fee. First, let's briefly look at the Galaxy Community in action. Galaxy Community is threat research for CISOs, and it's open to everyone, not just ArcSight customers. Galaxy Community translates the digital value chain into tangible countermeasures and deterrence methods. In a nutshell, this dynamic portal helps me answer the question, what are the risks that represent the highest impact to my business? Once I log in, I can drill down on the threats based on time period, regional risk, sector, or annualized loss expectancy, and so on. I can get more information on a threat by clicking on it, along with technical details, both high-level and details such as the MITRE techniques and tactics are provided. We have periodic publications. Ransomware is one of the recent ones. Briefings and threats also contain relevant information. We'll have a short demo about how ArcSight has right-click integration to this community portal later. GTAP provides always-on, real-time, high-fidelity detection and response, turning on the autopilot mode for ArcSight from day one. It aims to attack head-on the skill shortage and talent war challenges affecting today's SOC. Let's start our demo. As the analyst, I start my day in ArcSight's Respond UI, focused on the top left incident, which always reflects the incident with the highest criticality rating for the business. In this case, we're talking about Clop ransomware on a CEO laptop. I see that this incident was created by a real-time correlation rule. We now look at the incident timeline to get more context. Our CMDB tells us that this was Joe, the CEO, a VIP user in my organization. ArcSight Respond has also automatically placed a block action on my enterprise Palo Alto Panorama firewall so that we can contain the incident. But what precisely is wrong with this URL? Why does it flag as bad reputation? We will do a manual enrichment through our Galaxy TI service mentioned earlier. Without any swivel chair, I look at the results. Wow, 3 threat actors and 1 malware campaign, all with high threat levels, but also a manual override, high confidence rating. This is the creme de la creme of threat intel coming from the ArcSight CyberEz Galaxy service. It cannot get more high fidelity than this. However, as a new analyst, I've yet to build trust in the ArcSight TI solution, so I want a second opinion from VirusTotal, which is already available as part of the default playbooks. Okay, 7 other vendors also classified this as malware. We will now look at the auto-response actions generated for this threat. One playbook has been executed twice, once manually, once automatically. 2 actions have been taken on the PA Panorama enforcement system. If we feel that this was the wrong move, or the incident has since been resolved, we can simply revert the automated changes using the rollback button. Sure enough, we now rolled back the action and our CAO can once again browse the internet. It may prove helpful to look at some of the internals. The real-time correlation engine has multiple active lists to keep this TI data in memory updated also in real time. I can sort by name to see the latest and greatest. I can move around to see the world from Galaxy's eyes. The latest entries in this list are from today, which highlights the real-time focus of ArcSight. Let's now look at that single URL that was related to Clop ransomware on the CEO's laptop, along with 3 other threat actors. We have the confidence level here, along with additional context. This is critical data for speeding up the triage, arming the analyst with all the information they may need to make a final informed decision. Time is golden. This is an insider view into our prioritization formula. If an IOC has a threat level of high, we automatically turn any correlated alert into an incident. Let's now see who is behind this intelligence feed, the CyberRes Threat Research Team. Focusing on Clop, let's see where they came from. This is Clop ransomware's landing page hidden in the dark web, where they conduct their second stage of their double extortion ransomware attacks, something we've seen in the wild quite a lot lately. All the companies they've broken into are listed here, along with the actual data that was exfiltrated. Some innocent employees' PII data is also provided as a proof of value for any potential buyers, quite likely competitive organizations. Looking behind the scenes will show us many of the building blocks. This is the R&D portal into the CyberRes MISP server. Only we can access this page to manually refine the content following our own threat analysis. There are hundreds of organizations feeding into Galaxy. We are also just one of them, listed as CyberRes Galaxy, providing the premium content discussed earlier. There are thousands of entries with varying threat levels. The manual override high confidence is what we aim for, by ensuring that when we tag an IOC, there is absolutely zero doubt about its intended actions. As such, our customers can auto-block these without fearing that their legitimate business activities will be adversely impacted. Nothing good can come from these high-fidelity IOCs. I'll continue with the same example, our infamous URL from the start of this demo. All these tags were already in our SOAR response solution, but now we see how they came to be there in the first place. Same 3 actors and 1 campaign. I'll now check how trustworthy this information is. Let's see what else CyberRes says about Clop ransomware. So this is a URL associated with this ransomware. I'll also verify this information from VirusTotal. Sure enough, 4 out of 93 vendors have also given a similar malicious verdict, matching Galaxy. Additional details or community comments aren't shown here, but it is not important as ArcSight has already provided these details to the analyst automatically. I'll now mention some of the reasons we are able to provide high confidence, high fidelity, low false positive indicators. I won't read them all, but it's important for you to see that the research that's gone into this ecosystem. Our TI platform of choice is MISP, and we're loving it. We not only subscribe to these sources, but we also provide our unique research on top of it. Our premium TI is so high fidelity that, much like an inline IPS, some of our customers already use it in their real-time block decisions, even bypassing our ArcSight analytics engine altogether. They simply consume the GTAP Plus TI data and feed it directly to ArcSight SOAR to proactively block selected high-confidence IOCs. Another critical advantage is our 67 whitelists that belong to cloud and internet infrastructure, like VPNs and proxies, and that should never be blocked if we are to avoid a negative impact on the business. We also have introduced a kill switch into the Galaxy TI ecosystem. This ensures that we don't mistakenly block hundreds of systems if our Galaxy TI curation process mistakenly tags an excessive amount of IOCs with the manual override tag. Saving time for the analysts is our top goal. This is done through false positive reduction. Let's now talk about our free out-of-the-box GTAP Basic. Based on the public instance of the Circle MISP OSINT feed, this solution provides timely information on well-publicized threats. These entries are also kept up to date in ArcSight through the same Galaxy Smart Connector. High threat levels do exist, and we take those ones most seriously. In this case, it seems a Brazilian bank's domain name was hijacked. Let's now click on this other event with an APT tag. As expected, it has the high threat level. Only high priority IOCs can result in critical or urgent incidents, while medium and low IOCs play a supporting role but without triggering an incident by themselves. We'll now look at a Log4j event. Picking a medium event, we almost know where we're going with this. As expected, another false positive warning. This is in parallel with our priority decision process, like described in the previous example. Now, let's look at how quick this system is when it comes to publicly announced threats and vulnerabilities. For Log4j, IOCs were imported into the public instance of Circle MISP within minutes on that fateful day, December 10th, 2021. With our real-time integration, it also came straight to our servers and subsequently downloaded to the customer's environment with autosync within 1 hour of the original announcement. We'll now talk about the design principles and differentiators of the Galaxy TI program. According to our customers, the first and foremost inhibitor to adopting threat intel services for their SOC is lack of out-of-the-box connection to a reliable, always fresh, industry-recognized threat feed, which just works right from day one. Like in the real world, anything free actually comes at a price. Existing solutions seem to require the customer have a degree in rocket science just to get past issues like file format and protocol incompatibilities. TI consumers have been expected traditionally to leverage scripting language or OS configuration expertise just to solve synchronization issues or optimize performance problems. However, by definition, SOCs don't have the time nor such expertise to deal with these peripheral problems. They are under-resourced as it is. We solve this problem by embedding the MISP client into our Galaxy Smart Connect and further enhancing it. This is a high-level description of our TI feed flow. The customer only needs to install the connector, the black box in the diagram, and open port 443 to the threat feed server. This is how our customers have an always fresh copy of the dynamic and massive OSINT DB, synced in near time without hitting performance or network hiccups. The installation is also super easy, taking only 7 steps from start to finish, only stopping to ask the customer's preferred option based on their TI maturity or appetite level. Basic gets them this TI table stakes from day one without requiring any previous knowledge of ArcSight. Now, I'll show just how easy the installation can be. During this 7-step installation, there's no technical input needed from the customer except for their destination ArcSight server details right at the end of the wizard. Creating a smart connector was just a starting point. Making it easy was the main job. Let's see the second real-world issue. Before getting any TI data, consumers are required first to authenticate by presenting a token or key to the service. For example, Circle MISP usually requires the customer to register for a free account. In order to do that, the customer would first need to present a PGP key for their organization. Whilst not rocket science, again, the time and resource constraints faced by today's SOC teams simply leaves insufficient time or patience to go through this process. We solve this dilemma utilizing a less well-known technique hidden inside the MISP documentation. The secret lies in the JSON files available to MISP clients. We merged this feature with the AWS S3 caching feature, and the result was a high-performance, low-latency, real-time solution on steroids. We go to the CyberRes-hosted version of this MISP URL, and similar to an FTP client-server relationship, the Galaxy Smart Connector downloads these JSON files before converting them into ArcSight format. This method provides a unique and simple solution for this use case, where the customer is only really interested in a one-way download of the latest and greatest OSINT data feed. We have bridged the business view of Galaxy Community with our ArcSight solution. This is ArcSight Cyber DNA functionality. This capability enables the SOC team to proactively understand and assess adversary patterns. We'll demonstrate this through an OT-IT composite attack scenario. You'll see 5 things in this demo. The SOC analyst first sees an OT-IT alarm. They then want to view details of the campaign. Next, they analyze any actor motivation behind it. After confirming the threat, they will then deploy countermeasures. Finally, using Galaxy, they expand the operational coverage. This is the SOC operator view, showing the critical events from a SCADA perspective. Our analyst right-clicks on the red alert, showing a critical composite event, to drill down into the analysis. The instrumentation view comes up. Here we see the alarm, as well as a full set of OT telemetry data on the left, including vibration, temperature, pressure, and other sensory information from the refinery in the pipeline. We will double-click on the alert with a score of 9, which is the highest score. We then click the rule chain graph to track the traceability of the threat. This is where we confirm that the attacker indeed crossed over from IT to OT. Now, the analyst does a second drill down to look at the MITRE attack sequence contextualized within Galaxy. This is a kill chain visualization of all activities tagged with MITRE techniques. We change the dashboard to display from top to bottom. From here, another right-click drill down gives us the actor attribution level. This view provides a world of possibilities. First, we can see the adversary groups on the bottom left. Top right window shows the Galaxy IDs, also known as Threat Bulletin IDs, as used in the Galaxy Community Portal. Top left shows us the targeted sectors and threat actors grouped by parent countries. And finally, on the bottom right, we see MITRE Defend technique attribution for countermeasure mapping. Now the analyst drills down into the origin, the likely parent operations. This view gives us visibility of how these MITRE techniques are being used by specific parent origins. The next drill down provides us the tactical operations, such as what tools they are using, what campaigns they were linked with, what TTPs they are using, and so on. And more importantly, our analyst now knows that they have a threat in flight, prompting the deployment of suitable countermeasures. This view allows the analyst to understand what type of measures make the biggest difference. We then click on a sample countermeasure to understand which threats it will mitigate. D3BDI stands for Broadcast Domain Isolation Technique in MITRE Defend. This is a real-time view. Now we want to find out what other threats will be addressed through this same countermeasure. Another simple right-click allows us to query Galaxy directly. A customized Galaxy community page opens up in a browser window. Looking at related campaigns, we can now find out what other threats are addressed by the specific countermeasure, by the tactics being used, by the sector, and so on. Everything is linked through the Galaxy ID as shown in the URL. This ends this section of our demo. In scenario 18, we'll demonstrate ArcSight's native SOAR capabilities. ArcSight provides SOAR to its customers at no additional cost or license. All ArcSight customers can therefore benefit from SOAR's automated triage and response capabilities. SOAR automates the case triage steps with a sophisticated processing pipeline so that a standardized workflow can be prepared for the analyst when she starts her investigation and response activities. Alert filters let you customize parsing rules for building the case scope, while classification rules help you to define case classifications based on multiple configurable parameters. The consolidation feature of the processing pipeline allows SOAR to detect and combine related or similar alerts into the same case, so the analyst will have a full view of the related threats and response activities, all managed within a single case. SOAR can assign the case to an analyst or group, according to the organization's defined criteria. After any automated triage steps, SOAR runs a playbook for automated investigation and response activities, leveraging your existing SecOps technology stack, and connects the capabilities of different solutions to one another. Playbook designers can design their workflows easily and quickly with a visual workflow playbook editor. One click is all that is needed to add a new action or enrichment step, branching workflow to accommodate human decisions, and automation bits are just some of the powerful features of the playbook editor. In your playbooks, you add enrichment steps to provide further context to the nature of the threat, and automatically run a response action based on the information collected. SOAR supports human intervention within its playbooks. The analyst can be prompted for their decision at various points in the playbook flow. For example, the SOAR playbook can perform all the initial enrichment activities before then asking the analyst to decide the next step based on the threat context gathered thus far. SOAR also provides the flexibility to create code-based automations for more complex workflows, reusable design, and the creation of reusable libraries. Finally, all the playbook steps executed are automatically recorded in the case timeline. In scenario 19, we will demonstrate ArcSight Marketplace. ArcSight Marketplace is the main portal to provide the content needed for every ArcSight component, including analytics, detection, response, search and hunt, as well as third-party integrations. Our goal is to enhance our customers' content experience. We will also talk about our partner content, along with CEF certification. Let's start. By Googling, we reach the main ArcSight Marketplace page. Anybody, not just ArcSight customers, can sign up for a free account. ArcSight Marketplace offers a broad spectrum of content, authored by Micro Focus as well as our partners, the content authored by Micro Focus being free of charge. All partner-provided content is certified by ArcSight to our exacting security and performance standards. I now click on Palo Alto to see their offerings. They have a certified ArcSight CEF integration, which means that their log output will work with ArcSight from day one. I now click on ESM default content, a MITRE-aligned special package that also comes out of the box with ArcSight ESM. It has hundreds of correlation rules, most of which are enabled by default to provide meaningful detection and response from the outset. We maintain the latest version here on Marketplace to give our customers the rapid defense against latest threats without waiting for the next formal product release. Security Threat Monitoring is the first package, including TTP-based rules against adversaries. Threat Intelligence is the second of the two packages, working in conjunction with both our out-of-the-box Circle Mist-based Threat Intel feed, as well as Galaxy Threat Accelerator Plus, or GTAP, our premium TI subscription service. We also provide sample replay events to help verify correct deployments as part of the content development lifecycle. We offer another way to browse our default content, the MITRE Attack Navigator page. As mentioned previously in Demo 15, our default content is highly effective against a large number of MITRE attack techniques. Both pages are linked together so our customers can readily determine their MITRE coverage level. We now deploy those two packages to update our ArcSight system. Everything went well and the new content was activated without any downtime. Great, we can see the latest rules successfully imported. Finally, we perform an optional test to ensure that the rules are deployed correctly into production, avoiding nasty surprises down the line. Sure enough, the dashboards are all lit up with new alerts. The deployment was a success. We now deploy the latest Smart Connector framework and parser update to extend and refine our log coverage. We log into ArcMC through the centralized Fusion UI. ArcMC allows us to visualize and manage the entire log collection infrastructure, including event routing, collection architecture, health monitoring, and so on. We check the container details, and yes, we need to update at least one Smart Connector container. I upload the latest update file to ArcMC, which then distributes the update to all our specified containers as we see here. Finally, I see that the container is restarting, indicating a successful update. Now we will show how to download a SOAR playbook from the marketplace and deploy it onto ArcSight Respond. ArcSight customers can download their preferred playbooks or integrations to import into their ArcSight SOAR deployment. The import of downloaded playbooks is as simple as a single click. Imported playbooks then need some customization before being enabled for the first time. Their integration parameters need to be completed, their status and some other dynamic parameters are adjusted for successful execution within a production environment. Once customized, the new playbooks can be enabled or executed either automatically or manually. Playbooks and integrations work hand in hand. Integrations can also be downloaded from ArcSight Marketplace to extend out-of-the-box capabilities. This ends our demo. Thank you.